Hello, this is Mohan Kelkar. In this video, I want to talk about the footprint of various energy resources. According to Oxford Dictionary, the definition of footprint is an area occupied or affected by something. Anytime we extract energy from nature, whether it's subsurface or on the surface, we impact the surface in some way. I do want to distinguish between gas and oil wells and coal mines. Compared to coal mines, the surface impact of oil and gas wells is quite small. The surface mining of the coal definitely has much bigger surface impact than a typical oil and gas well. In this video, I just want to concentrate on oil and gas wells. The modern hydrocarbon development had changed significantly. Because of our ability to drill wells at various deviations and various angles, we can connect to large portions of the reservoirs from a single location. So although the surface location is small, we can connect to large parts of the reservoir either vertically or aerially. As can be seen from this picture, we have three wells here where the three heads are located. Although these three wells are connected to different horizontal wells and we are connected to large portions of the reservoirs, although the surface facility is quite small. In addition to wellheads, we also need the surface facilities to collect and gather oil and gas, separate oil and gas and water, and then ultimately sell oil, gas, and water. Similar to that, wind farms also require large surface area. The average life of a wind farm is about 20 years, and based on how much energy we can generate from the wind farm, the typical power density, this is the amount of energy which is collected per unit area, is between 0.0006 to about 0.002 kilowatt per meter square. Solar farms also can take up large areas, and the typical average life of a solar farm is about 20 to 25 years, and power density according to government website as well as ysgsolar.com, which has collected large amount of data from the largest solar plants in the world, is somewhere between 0.01 to 0.07 kilowatt per meter square. Now we can compare the power density of oil and gas well compared to wind and solar farms. I made some assumptions with respect to oil and gas wells which are reasonable. I assume the life of oil and gas well very similar to wind farm or the solar farm, which is about 20 years. I assume that an oil well produces about 100,000 barrels of oil. An average gas well produces about 2 billion cubic feet of gas. The well will occupy about 100 square feet of surface area at the production site where the head is located, and about 5,000 square feet of surface area for processing the fluids which we produce from. Using these assumptions, the power density for oil well is about 2 kilowatts per meter square, and for gas well, it's about 7 kilowatt per meter square. When we compare the power density of various resources as done in this graph, on x-axis what we see is the power density of four different sources: wind farm, solar farm, oil well, and gas well. And wind farm is about 0.001 kilowatt per meter square, solar is about 0.03, and oil well is about 3, and gas well is about 7. Please note that the x-axis is a ratio graph, it's not linear. And then what you see on the y-axis is the ratio of power density, gas compared to other power density sources. So from this graph you could see that the gas well is about 7,000 times more efficient than wind farm in terms of power density, and the gas well is about 300 times more efficient than solar farm. What we have not compared is what happens to the gas wells and oil wells and the surface facilities after the life of the well is over. That is true for solar farms as well as wind farms, and that will be the discussion of the next video. Thank you for watching it. If you like it, please subscribe to my channel. Thank you.